easier to understand. Some services that are important to be performed in any Wi-Fi are listed here. Okay, association, which is the process of making sure that you get identified by an access point, and the access point knows that you belong to its group of users or stations. Okay, the second one is authentication, deauthentication. So this is just to, and again, dissociation. So this is to establish, this is to break it down, to authenticate into the system, and you can think of this as logging out of the system. So logging in, logging out, okay? Distribution is the process of taking the information from one basic service set to another basic service set, okay? The functionality that takes that through the backbone, so changes the information to be compatible with the backbone and then convert it back to become a basic service set, is called the distribution process, okay? What do I mean by this? Okay, the example is very simple, and I think describing it with protocols is gonna make it easier. So as far as your access point is connected to your device, you don't actually need IP at all. You can only connect using the MAC address, and you can exchange information with the access point, between your device and the access point. Now, if you want to access something on the internet, or you want to access a device which is connected to another access point, then what you do here has to go through some backbone. Okay? If that backbone is just the Ethernet cable inside Qatar University, and you are not using any IP services, okay, then in that case, we convert, the distribution is going to convert the Wi-Fi protocol to an Ethernet protocol. So the packet formats and everything is gonna be switched from one protocol to the other, send it to the other side, and then at the other side it's converted back to Wi-Fi until it reaches the other station or the other node, okay? That process of converting and converting back is called distribution, okay? Integration is basically group of distributions. That's the cloud, that's the functionality performed at the cloud completely, okay? MSDU delivery, that's the process of taking the information and making sure that it gets transferred from the source inside the packet to the final destination. So what does this involve? At the transmitter, it involves putting the MSDU and then surrounding it with the headers to format the MPDU, right? At the destination node, I want to get only the information, so I will remove all the header stuff and I will extract that green part, which is the MSDU back again, okay? So that's called the MSDU delivery. Privacy, you know what's privacy? It's the process of protecting the information, okay? And finally, resociation means that you connect it to this access point, you disconnect it from it, and you connect back to the same access point. That's the resociation, okay? Reassociation, okay?
Why do we call it different than authentication?
Authentication is something and association is something else. So I can be associated with this access point, but I'm not authenticated to access some information, right? So authentication is a different level from association. Association is just making sure that I have a physical connection with this, okay? Okay, now we are finished with the generalized description of the Wi-Fi connectivity, or the general description of the networking of the Wi-Fi. When we start talking about 802.11i, we are talking about the security aspect of the Wi-Fi network, okay? So the 802.11, don't forget, 802.11 in general is Wi-Fi. 802.11b, A, N, G, AB, AC, all of these are different versions of the medium access control and logical link control layers, as well as the physical layer, okay? But they all still fall under networking of the Wi-Fi. 802.11i is specifically for the security of Wi-Fi. So it still talks about Wi-Fi, but the focus of this part of the standard is only on the security aspects, okay? Now, last time you have been informed already about the WIP and the WIPA, right? So the WPA and the WIP. WIP is like the oldest security standard in the Wi-Fi. It's called the wireless equivalent, wire equivalent or wire equivalent protocol, right? And it talks about the description that you have been told about, which is basically hashing, and then after that, encryption. And the biggest flaw was that you use something called network vector, NVI or IVN, initiation vector, the IV, yeah, the initiation vector. And the problem is that initiation vector is part of the encryption, but it's also sent in plain text. Okay, this allows you to do something called cryptanalysis. Cryptanalysis means that if you have some parts of the transformed information in plain text, and then you have access to the encrypted version of that, statistically, after a few number of trials done in a careful way, you can actually figure out the key. Because I have the plain text, I know what the information being sent right now is, and I have the encrypted version. By doing some combination of those and enough number of trials, which means enough number of packets going in front of me, I can actually figure out the key. And the weakness was not only that the IV was making the key shorter, but it was also because the IV is part of the encryption, so it's being used as part of the key, right? And it's being sent in plain text. So if it was just deduced and you end up with only 40 bits, right? And instead of 64, right? So if you ended up only with 40 bits, but it was not sent in plain text, still the system would have been stronger than what it is at right now. The problem is you had it also as plain text, okay? So anyways, that's the whip.
This is our project.
Yeah, inshallah. This is where you, both by the way, you will break both. But this one guaranteed to break. This one, you will try, you might be able to break it, you might not, okay? So the WIPA is a little bit stronger, and the way you break into it is kind of statistical, and it might succeed, it might not. Depends on many things, okay? Most of the time you will succeed, don't worry. Now I'm talking about all the groups, okay? So anyways, and then later on the advancement, moving from the WIPA and WIPA, we came to something called WPA2, which is called now the Robust Security Network, and this is where the 802.11 I comes into the picture. So these 802.11i is the naming of the standard defined by the IEEE. The Robust Security Network is the naming of that under the Wi-Fi Alliance. Okay? So the name Wi-Fi did not come really from the IEEE. The name Wi-Fi came from an alliance of industrial partners who are working in that technology, and they decided to call the 802.11 Wi-Fi. Okay? And then they also have names for other things similar to, for example, the RSN, which is basically the 802.11i. Okay? And it used an enhanced version of WPA called WPA2. Okay? That's the RSN as well. Okay? Now these are some of the functionalities or the key functionalities performed by the RSN, okay, in terms of services and protocol, as well as the algorithms being used for the cryptography, the encryption and decryption. Okay, so as you can see up there, there is the access control part of the security aspect, who gets into the network and who does not get into the network, and for that they used a port-based access control. So I allow people who work on a certain, or allow access through certain ports, and I prevent other ports. Ports are logical naming for physical connection of stream of data. So I connect to this access point to send some data, and I want to connect with two different data. One of them is going for the HTTP, because I want to access a website, and another where I'm still running another program on my computer, for example, and I want to access through the access point to, for example, download a picture. That's an FTP protocol, for example, okay? So these are two streams going in parallel. How do I identify each one of them from the other? I give them a logical identifier called the port number, okay? So the one going for the HTTP is gonna carry some port number. The one going for the download is gonna carry another port number. So that's what's called a port. A port is an identifier for a logical stream of data, And there are specific ports for specific services. So the HTTP have 2 or 3 different port numbers that you can use. The SSH, the secure shell access, has another port number, the FTP port number 21, if I remember correctly, for FTP, and so on, right? So those are specific or fixed port numbers for certain types of services, okay? So for the 802.1 port-based access control, right? This is what's used as part of the RSN, the 802.11i, okay? We have, I think this is 802.11. It should be either 1x or it should be 1.1. I don't know why it's written this way. I'll double check it, okay? Authentication and key generation, that's another functionality. And the methodology used there is called EAP, Extensible Authentication Protocol. So that's a protocol that defines how you do the authentication. What are the steps that are followed to authenticate? And then the key exchange, TKIP and CCMP. This is for confidentiality and data origin identification. So basically, call this what? Authentication of data origin. We called this what earlier? Authenticity of the data, right? Yeah, so that's for the authenticity of the data as well. Now, under the encryption, decryption, there are several algorithms that are being used to do the encryption and decryption process. One of them is the encryption, decryption itself for confidentiality. The other one is for the integrity of the data. This is the hashing, for example, the hashing functionality. And the third one is, for this to work, you need to generate keys and exchange keys between different parties, and that's called the key generation and exchange protocol. Okay, so these are sub of the services related to the confidentiality part. Okay, all of these are part of the confidentiality, more related to the encryption decryption process in the 802.11i. Here is an example of how you do association, secure association in 802.11i. So you start by a phase called discovery. This is where basically you look for different access points around you, right? And in that case, the access point is making itself announced to people who wants to access it, or you know ahead of time what's the name of the access point and you enter it by yourself, okay? That's called the discovery phase. And then the next phase is to actually pass in your passcode to say that I am authentic to get into this network, right? And in that case, this association server is sometimes, or many cases, it's actually a small piece of software inside your access point. It doesn't have to be really a separate server, but in terms of the functionality, you should think of it as a separate server. Or in the case of something like Qatar University, it's not simply a password that allows you to connect to the Wi-Fi. You are actually connecting to an authentication server that checks your email and password and then makes sure that you are allowed to connect. Then it allows you to connect to the access point. So if you want the full example, it's when you connect to this Wi-Fi at Qatar University using your email and password, right? Yeah, so you use an identifier which is not simply a pass between you and the router similar to what you do at home, but it's actually an identifier that identifies you to the backbone of the network, and through that you're allowed access to the Wi-Fi access point, okay? So that's a good example where the authentication server is being employed. It's not simply through the access point, but through some back-end server that says, yes, you are allowed to get into the network, okay? And then key management, after doing that, in order to make sure that your data is encrypted and secure and nobody can hack into it, there is some exchange of keys between your device and the access point, so the data goes and comes back encrypted correctly. Last part is the exchange of the actual data. So here only making sure you agree on the key, and then here you are exchanging the actual data, okay? Eventually, you disconnect, you go outside the network, you don't want to connect to the Wi-Fi because it's very slow and you want to connect through 5G, then you go through this phase where you say, I want to disconnect from the network, okay? So you dissociate from the network itself. Similarly, there are many other operations that are described. I don't want you to kind of memorize those operations, but it's a nice idea to look at the different phases that goes through these operations. And if you have questions, come and ask me, okay? Okay, if you want more details, read a little bit in the book. We are not here to memorize these operations, but we only want to understand that they happen through a certain predefined protocol and they go step by step. Okay, be ready at any point in time that I might give you something totally different from this. So for some other protocol that is concerned with security, and then I just want you to be able to understand and read these diagrams that are called time sequence diagram. They basically have actors, devices, or device and a user or whatever, and then messages being sent, and in some cases replied to. So I request something, I get an answer for that, then I take another action, I get a response, and the response might be from this or might be from that. It might be from here to here, from here to here, and so on. Okay? Just try to get used to understanding time sequence diagrams. Whether you represent some action into a time sequence diagram, or you look at a time sequence diagram and answer one or two questions about what's happening here. Okay? Yes?
Is this a time sequence diagram?
Yeah, that's a time sequence diagram, but it shows you that there is a delay as well. So this one considers things happening like instantly. But if it says that between sending the request and the receiver getting the actual request, it goes down here, it means there is some delay, so it encounters or it accounts for the delays as well. Yes?
Look at the previous slide. If you go over there, when it came to termination of the communication. So if that requires a request, how do our devices deal with it when, let's say the range drops out or?
It times out. It doesn't always require a request.
Okay.
It's just if you leave the network, so to stay connected to a Wi-Fi access point, you keep sending something called a life, right? And also the access point keeps every now and then sending something called the beacon, okay? Bacon, B-A-C-O-N, bacon. Okay, it has nothing to do with ham, ham and bacon, okay? So it's not food, okay? Okay. And this is like a small piece, you know the thing that they hang for SOS?
Yeah.
And it keeps sending beep, 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 right? That's called the beacon. Something that repeats, a signal that repeats over and over again to say there's something here that needs to pay attention to. Okay? ممكن أجاوب على السؤال بتاعه بس الأول. I will answer his question and continue. Okay? Sorry. Yeah. So basically, if this gets lost after a certain timeout, then the two devices are disconnected from each other. Yes, اتفضل يا
I mean,
أستاذ.
I thought it's named beacon.
يمكن السبيلنج غلط يعني ولا؟
Yeah, but, is it the same thing?
هو the same thing. هو beacon, beacon, bacon, whatever you like to say. It's the same thing. Yes. Yeah. You are talking about the same thing that I'm talking about. Okay. Maybe it's B-E-A-C-O-N. Maybe I don't remember the spelling yet. Okay. Okay, Shabab. So the remaining couple of slides, I'm gonna go through them in 1 minute. معلش. Okay. So here, for the particular part of access control, there is a specific standard. So IEEE 802.1X. Remember when I told you a couple of slides ago, it should not just be one, it's 1X. Yeah. So that's the correct one. This is the sub-standard of the IEEE 2.11I that talks about the access control specifically. Okay. And again, in this case, there are two modes of operation: the controlled port and the uncontrolled ports operation. Controlled ports means I do not allow anyone to access through the access point except for specific ports that I keep open, and the other ones I close them. Okay? The uncontrolled means you can connect through any of the ports, any of the possible port numbers, and then the authentication happens behind that. The first is considered more secure but more restrictive. The second is less secure but allows a wider access to authentication and access control. Okay? These are, again, a list of, just for your reference. I don't want you to memorize these, but this is a list of the data confidentiality and integrity protocols that are being used within the 802.11I. Remember, there was access control, there was confidentiality part. There are many different protocols and different identifiers. No need to memorize them. An important thing is the pairwise key idea. Okay, so originally in the web there was only one key. being used for encryption and decryption. And then in the WEPA, there are two keys. There are two parts of the keys, a shared, so two shared keys. One of them is called the private key, and the other one is called the public key. And then in the WEPA 2, that's the more advanced protocol, there are three parts for the key. Okay? The whole idea here is you are trying to minimize the amount of keys that are visible to anyone looking at the network from outside. Okay? This is again another breakdown of the functionality of the PTK, or the exchange of keys functionality. And again, it's just for your reference. We don't need to go through it one by one. Last but not least is the exchange of information. There are two techniques, or two important parts for that. The temporal key integrity protocol, the TKIP, which is dealing with exchange of keys and making sure that they don't fall into the wrong hand. And the other part is the counter mode CVC MAC protocol. And this one is devices that are equipped with hardware to support a particular scheme. So this is a kind of message integrity and data confidentiality together, but it is a more advanced system as opposed to the TKIP. So the TKIP is a less advanced one, but this one requires newer hardware, the CCNP. Okay. Again, you don't need to memorize these things. It's just for your reference. Okay. And we are done. Sorry for taking